For the first time ever, I am thrilled to say we have an official sponsor for the Dirt Talk podcast, and that's Ariat. I've worn Ariat boots on every job site I've visited over the years, traveling in them across 5 continents. More importantly, I have yet to find a single project where working folks, unlike me, are not wearing Ariat boots and workwear in every condition imaginable. And there's really good reason for that, and that's because it's phenomenal stuff. And the more I've learned about Ariat and the company, the more I've loved their brand. So with this, Ariat is offering any Dirt Talk listener 10% off their next Ariat order at ariat.com/dirttalk. That's 10% off boots, jeans, and workwear at ariat.com/dirttalk or at the link in this episode's description. With that, let's get to the show. All right. Hello, everybody. Welcome back to the Dirt Talk podcast Monday edition. Today is exciting. I worked on this all night to summarize how iron ore mining works. I am going to dig in on this episode to a visit we did this year to the Pilbara, which I'll explain momentarily, the world's largest iron ore region. And I'm also going to highlight how iron ore mining works in general. And before I dig in on this, we have 2 YouTube videos that are published summarizing this entire process. So everything I'm about to talk about is also in video form. If you search my name, Aaron, Aaron Witt, Witt on YouTube, you'll get to see 2 amazing videos featuring Rio Tinto and the Pilbara, and hopefully you can enjoy those as well. But here, we're in audio format, podcast format, so we're just going to focus on the facts, on the information. And to get right into it, since high school, I've looked at these photos of a specific region with amazement. And it's a region called the Pilbara. And this area is situated in Western Australia. And it looks like this barren expanse of orange-red dirt desert to the untrained eye, which is, I think, quite beautiful. But to anyone that knows anything about mining, this is one of the world's most valuable regions in the world. And that's because of one thing called iron ore. Now, the Australian Mines Department extensively surveyed the Pilbara following discoveries of iron ore as early as the 1930s. And then in the 1950s, the state government of Western Australia tirelessly lobbied to the federal government to end iron ore export restrictions, which would have allowed them to mine and send iron around the globe. So back in the day, largely because of World War II, Australia restricted the export of commodities, including iron ore, which then made the commodity less valuable because the market internally within Australia was obviously much smaller. So once they made these discoveries, they said, hey, federal government, let us go sell this on the open market because it's going to be a great thing for everybody here. And then once the government began easing export restrictions, in 1960, the floodgates opened with large mines coming online after very brief development periods. So in 1968, iron ore production was about 20 million tons in a 1-year period. Today, the region exports over 850 million tons of iron ore annually. And with new mines still opening and existing mines undergoing expansions, the Pilbara's iron production is not slowing anytime soon, and it very easily could exceed 1 billion tons of iron ore every year, which is just staggering. That is a lot of metal rocks. Now, with so many mega mines, you can imagine why Western Australia was high up on my list of places to visit when we returned to Australia this year. So as I was planning the next Australia trip, I needed to go to the Pilbara, but I needed a way in. It's a tricky place to get into. But thanks to relationships that I've built with Rio Tinto Kennecott here in the United States, we managed an introduction to Rio Tinto's Australia team. And when I asked to visit their new mine in the Pilbara called Gudai-Darri, They also asked if we wanted to check out the rail and port operations. And it didn't take them very much pressuring me to get me to sign up. I promptly signed up. And we scheduled 2 days visiting not just the mine, but the rail operations and port operations, which I will cover in detail momentarily. So if you fast forward a few months, we were boarding the first of 3 flights of the day, starting from one of Australia's other major mining regions called the Bowen Basin. But that is another podcast. We first flew from Mackay to Brisbane, and then across Australia to Perth, which took about 5 hours, similar to going coast to coast in the United States, to about roughly the same distance. We then met our guide from Rio Tinto, Phoebe, and switched terminals to our final flight of the day. And the terminal we left from serves all of the region's mines, with hundreds and hundreds and hundreds of workers, all wearing high-vis, flying out of there every week. It was quite funny being in an airport. Everybody there was a miner. And they call it FIFO, which is fly in, fly out. And most of the Pilbara's workforce lives in Perth or surrounding areas in the city, and then commutes to the mine via chartered aircraft on 1 week, 2 week, or 3 week rosters. So you live in Perth, you go to the airport, you fly to the mine, you work for a week, you fly back home, you're off for a week. It's a really, really cool deal. So we boarded the plane destined for Gudai-Darri, and we landed on the mine's private airstrip about an hour and 15 minutes later. It's a shorter flight. So walking down the boarding stairs onto the tarmac, we immediately noticed something: the flies. And seemingly thousands of these things swarmed us almost immediately. It was incredible how fast they found us. And they tried to get up our noses and our ears. They would get in between my glasses and my eyes. And it was so bad we couldn't stand outside. And we had timed our visit perfectly for when the flies are typically the worst. They ebb and flow. Sometimes of the year they're not there. Sometimes of the year they are absolutely everywhere. People had warned us before we got there about the flies. I thought it was going to be like, oh yeah, flies are kind of annoying. But this was next level. You couldn't be outside. It was that frustrating. We then met our guide at the mine site, and he quickly ushered us into a fly-free, fortunately, Toyota Hilux pickup. And then we made our way to the camp to check in and drop our stuff off. So Gudai-Darri is Rio Tinto's most advanced and modern mine. So the entire operation is new and gorgeous, starting with the camp. We checked in. TJ paid someone $50 for their fly net because he was so bothered by the flies. And then we dropped our stuff off at our rooms before the night shift. So each one of us had our own room within the camp. And the camp has everything you could ever want. A giant cafeteria with delicious food, as much dessert as you want, and even steak cooked to order, which I took advantage of. A really, really nice big gym, a pool, athletic fields, even a pub. Everyone has their own room for the week while they're working on site, and the rooms include the basics like a comfortable bed, television, bathroom. And then as we walked down the outdoor halls, it's an outdoor camp. Many of the doors had night shift magnets on them, which indicated those sleeping during the day. It's a 24-hour operation. Then as the sun set, we enjoyed our steaks and hopped into a Land Cruiser for night shift. And this wasn't any Land Cruiser. It was equipped with special technology for the Autonomous Operating Zone, or AOZ, where the mine's autonomous trucks roam. And like any other major mining operations or regions, the Pilbara never shuts down. Mining happens every hour of every day of every year, which means about half of the mining happens in the dark. So we cruised through the dark along the haul roads until we reached 2 production units, CAT 6060s, loading autonomous 793 haul trucks. Our guide showed us the computer system, which enabled us to communicate with the autonomous trucks and stay within a locked area so no trucks could go where we were until we removed said locks. The autonomous system is quite amazing. I've seen both Komatsu and Caterpillar system. This is Caterpillar's MineStar system. And for safety, the truck, like I said, has a receiver on it. So all the other trucks, or the light vehicle that we were in, has a receiver on it. All the other trucks know where we are at any time. And then when we park up, we tell the trucks, hey, we're in this area. You cannot come into this area. We lock out that zone. And until we remove that lock, trucks are not allowed to go into that area. But that lock we placed outside of the haul roads, outside of the loading areas, so the trucks were able to continue moving while we were out there watching, which was very cool. And so we watched the shovels load for a while. But at this point in the day, after flying across Australia on 3 flights, we were completely smoked. So we returned to camp and slept well before our full day at the mine during daylight hours. Next morning, I worked out at the gym, which was great, and then had a killer breakfast. And by sunrise, we were headed out to the operation to learn exactly how it all worked, which was my first official day in the Pilbara, and certainly, hopefully, not my last. I love it out there. Before I dig into the mining operation, though, itself, just a few basics, some housekeeping. Steel makes our world go round. So it's cars, buildings, power. None of that would exist without steel. And steel requires 2 main ingredients, coal and iron ore, which makes iron ore as critical to humanity as it gets. Without steel, humanity falls apart, literally. It's the support system of our entire humanity and society. And Rio Tinto has 17 iron ore operations in the Pilbara, which is completely bananas. Gudai-Darri specifically started in 2022 and will operate for 40 years at an annual production rate of over 40 million tons, which is completely nuts. It's just staggering how much material comes out of this region. So to get back to the mining process itself, the first step of the iron mining process is similar to any large mining process, and that is drilling and blasting. Rio Tinto operates a fleet of Caterpillar autonomous drills, which they control from a central location about 1,500 kilometers away in Perth. The neat thing about the autonomous drills, this is something I haven't considered previously, is that they can continue working within the blast exclusion zone while all other people must evacuate for safety. So they're shutting the operation down every so often for blasting. So any person needs to leave a certain radius around the blast, but the autonomous equipment can still continue working even when the area is shut down. The drills typically drill about 12-meter holes, which is roughly 40 feet deep, and the crews take a sample of the iron ore from each. Every sample then makes its way to an on-site lab, which uses robots to process them and determine the iron ore grade for later blending. I'll cover that in detail in a moment. Using the drilling information as well, the blasters then load every hole with emulsion. The trucks they have use GPS, which allow the blasters to load each hole with the exact emulsion required for the perfect blast. So the drilling data shows the blasters how hard that rock is, and then they can calculate how much of the explosive they need in every single hole, and that truck knows so that the blasters can load each hole with the exact amount. Each hole can be different. Absolutely spectacular. So then you blast, kaboom. Blasting happens daily, sometimes multiple times every day, to keep the material ahead of the mining fleet. You have a mining fleet that big, it's very hungry. You can't outdig the blasters. You got to keep blasting consistently to make that happen. And then speaking of the mining fleet, the mine currently operates 26 autonomous 793 haul trucks and 5 6060 excavators, 2 994 loaders, and a wide range of ancillary equipment. The 793, which is a little over a 300-ton truck, is the gold standard in the Pilbara. That size class truck, I believe it's the Komatsu 930 is the equivalent. For the distances that the trucks run, it's the most efficient. So you would think a bigger truck would be more efficient, but not necessarily. These smaller trucks, quote unquote, are the ideal truck for the region. And there are hundreds and hundreds and hundreds and hundreds of them, more of them there than anywhere else in the world. So thanks to the testing I mentioned previously, the mine knows exactly what ore grade each loading tool is digging through. So then the system uses that information to prioritize certain machines with trucks based on what grade the plant requires at any given time. They must blend the iron ore to create a perfect grade that the steel mill can consistently count on, which is why the operation always monitors ore grades and plans accordingly. So as you're digging through the earth is not consistent. There's different grades of iron throughout the mine. And so they know what grade is where based on the drilling information testing. And so as the 60/60, as the bucket breaks through different areas, according to GPS, the computer system knows what ore grade is in that bucket, which then knows what ore grade is going into that truck. And then they know what ore grade the plant needs at any given time, which can fluctuate. So based on what it needs, the system can optimize the trucks to say, hey, this shovel over here is in the good stuff. We're going to send more trucks over here, stock this excavator operator up on trucks so that we can get as much material to the plant as possible. And then over here, this ore grade we don't necessarily need. So we're going to send these trucks to the stockpile right now, and we can pull from that ore grade later. It is so cool. And because the trucks are autonomous, they only stop for fuel and cycle themselves through the shop for PMs as needed. All other equipment is manned, and everyone I spoke to was very complimentary about the autonomous system pioneered in the Pilbara decades ago, thanks to its consistent conditions. I asked everybody what they thought of the autonomous system, and even people out there first said, hey, I wasn't very positive about it up front for obvious reasons, but it's actually been a great thing. It helps them be more efficient. And one guy in particular said that operators really like it because instead of doing years in a truck before getting a shot at a grader, a dozer, an excavator, whatever it is, you get those opportunities a lot faster, and they train you up on those opportunities faster, which I think is really cool. And then before I get to the plant where the trucks are hauling the material, it's worth mentioning the stripping ratio, which is only about 1-to-1, meaning they must remove 1 part earth for 1 part iron ore. And that is incredibly low compared to other commodities. Some coal mines I've been to can be 30-to-1. So they need to move 30 parts earth to get 1 part coal. This is just 1-to-1, which is spectacular. And now each truck brings the ore to the crusher, where the massive machine sizes it before dropping it onto a conveyor, feeding the plant at about 8,000 to 10,000 tons per hour. The plant is much simpler than some of the other plants we've seen. All it does is size it to create the different products with enormous shaker decks. The bigger stuff is the premium blend, while the fines are a secondary product. So after the crusher, the material drops onto a conveyor. That conveyor feeds it into the plant. The plant shakes it a bunch to size it based on different screens. You get 3 products out of that sizing. You get oversize, which then circulates back to another crushing circuit to make it a little bit smaller. You've got your premium product, which is lumpy, but not too lumpy. And then you have your fines, which is a secondary product, still iron ore, but goes into a different pile. So after the plant then, the blends are moved to enormous stockpiles before being loaded out. The mine can keep roughly 1 million tons of finished iron ore on site at any given time. Then when it's time to load a rail car or rail cars, they use huge reclaimers, which are basically bucket wheel excavators, to grab the ore from the stockpiles and transport it by conveyor into a silo, which it then drops into each rail car from. Each train is about 240 cars and carries a little over 28,000 tons of ore. Loading each train takes about 200 minutes, and the operation loads between 5 and 6 trains every day of the year. Which then gets me to the rail side of things. So Rio Tinto, as I've alluded to, doesn't just own and operate 17 mines, but they own and operate the entire supply chain, including transporting the ore to market. So they operate and maintain about 1,900 kilometers of rail, which is about 1,100 miles, and 220 locomotives to connect their mines to the coast. which also is one of the largest private rail networks in the world. The locomotives are diesel electric, and you guessed it, are also autonomous, run from the central command center in Perth. Each train, which consists of 240 cars and 3 locomotives, barrels its way across the Pilbara to reach Rio Tinto's port, known as Cape Lambert. So we, to get up there, flew from Perth. We stayed the night in Perth, got on a plane, and flew up to Karratha, which is, if Perth is in the southwest corner of Australia, Karratha is kind of up in the southeast corner of Australia. Northwest corner of Australia. So Perth, southwest. We were up in the northwest corner then. The Pilbara is kind of up in the northwest corner, but more inland. So all of the iron ore needs to come from inland Pilbara and travel in that northwest direction up to the coast to get put on ships. So once each train, Rio Tinto's train, reaches Cape Lambert, it's time to dump the cars. The dumper rotates 2 rail cars at a time, dumping the iron ore into a chute below, feeding it onto a conveyor. And this process takes less than 1 minute per car. So it's this giant contraption. You don't have to uncouple the cars. The couplers rotate, grabs 2 cars at a time, rotates them in line with the rest of the cars, rotates them, dumps it out, rotates them back, puts them back, wheels out 2 more, repeat. 240 cars, 2 at a time, so 120. Fast math. I have an engineering degree. The material then drops onto conveyors, and this facility features 150 conveyors reaching from 6 meters to 3.5 kilometers long, which is about 2 miles. They transport the material to stockpiles, then sorted by product. There are 56 stockpiles on the site, each with about 6 trains of iron ore. So these are massive piles. Then when it comes time to load the iron ore into ships, more giant reclaimers use their bucket wheels to scoop up the ore. And then it moves again by conveyor through shaker decks once more to ensure the correct gradation. Then onto the 2 longest conveyors at the facility, which feed one of 2 wharves. The longest wharf, CLA, is 3.5 kilometers into the Indian Ocean, or slightly over 2 miles. Each wharf has 2 ship loaders, meaning the facility can load 4 bulk carrier ships simultaneously. Most ships will take about 150 to 200,000 tons of iron ore, which takes about 24 hours of loading. And then from there, the ore heads to steel mills worldwide to become the essential material we need, steel. And it's quite interesting when they load the ships, they have to load them evenly. So they don't fill up one compartment at a time. They have to fill a little bit over here, empty some of the ballast tanks within the ship as they do so, then go over here, fill a little bit, and they somewhat rotate through that ship to fill it all the way full of iron ore. The bulk carriers are these giant cargo ships with an enormous empty space in a majority of it, and they just fill it all full with that iron product. It was spectacular to see. We got to go out onto the CLA wharf, so we were out in the Indian Ocean. Beautiful, bright blue water, warm. First time seeing the Indian Ocean. It was something I will certainly not forget. So that is the iron mining process. From A to Z, from blasting to hauling to crushing to processing to transport via rail to then loading onto ships for worldwide steel production. This is, like I said, one of the most critical regions in the world, and it's a region very critical to the Australian economy. And I am so excited that we had the access and so excited to go back one day. So before I wrap up, huge thank you to Rio Tinto. They were very, very, very easy to work with. Being such a big company, remarkably easy to work with. They allowed us to see anything we wanted to see, show anything we wanted to show. And it's been a real pleasure working with them. I'm just over the moon to be working with a company like that and have access that have the access that we do to these operations. So thank you to everybody in the Rio Tinto camp. It was an extraordinary visit. I'll never forget it, and I hope to be back soon. As a reminder, we have those 2 videos now on YouTube. You can just look up my name. You can find them, watch them. They're great. We got a lot of great stuff. We used a lot of Rio Tinto's footage as well to tell that story. And hopefully, now after listening to this podcast, you understand a little bit better how the world works and how iron ore is mined. So if you have anything else that you want me to dig into, as always, send us a note, dirttalk@billwood.com. If you enjoyed the podcast, share it with people that might enjoy it as well. We really appreciate you sharing what the heck we're up to grow the show. If you want to support us, you can go to dirtworldstore.com to buy stickers, calendars, hats, shirts. We've got all kinds of stuff up. We fulfill it in our warehouse, which is on the other side of this wall here from the studio. And with all of that, we will see you on the next one. Stay dirty, everybody.